we're going to come back to solving equations that are quadratic. That is, equations that have a highest power of 2 appearing. And when we had discussed things before, we had only handled solving those types of equations by factoring. Unfortunately, factoring only works sometimes. There are plenty of different kinds of quadratic expressions that can't be factored, so we need other ways to be able to handle things that will then bring in our recent knowledge about square roots and complex numbers. To do that, we've got 3 new methods: the square root method, completing the square, and the quadratic formula. And these are all related to one another. They're kind of like, building on each other, really, so that what we get is a more complete selection of ways that we can solve equations. If we can factor, wonderful. Hopefully we are skillful enough and fast enough at doing that that becomes an easier sort of process than going with one of these other options. The square root method is another one of the methods that only works sometimes, so there are certain types of problems that might lend themselves more directly to that square root method. Basically, if we're forced to do completing the square, that's the only time that we want to do that. Otherwise, we want to try to instead use the quadratic formula, which comes out of completing the square anyways, and is just a much faster thing for us to usually use, just a less complicated sort of procedure for us than completing the square. Completing the square, however, is something that we will find useful as we move along into other algebra topics. So the farther along that you go with math courses, the more you may see that completing the square is occasionally necessary for you in different sorts of situations. So we do still at least want to be comprehensive about covering that, even though we're going to only limit that to when they absolutely positively tell us you must do completing the square. To start out with, the square root method, again, out of these 3, is the more straightforward, but it will only work sometimes because it will only work with problems that are set up in a very particular way. We have to have what we call a perfect square, which means that we would have to have something like an x squared and no other variable x showing up anywhere else, or we would have to have in parentheses x plus a number or x minus a number, and outside the parentheses we have that power of 2. And again, the x doesn't show up anywhere else. So that's a very limited sort of situation to have, which means that that's only going to work on those particular types of equations. One of the key features about using this square root method is that we have to remember that if we've squared something, the thing that has been squared could be a positive, or the thing that was squared could be a negative. So we have to make sure that we account for both of those different possibilities and end up with the maximum possible 2 answers that could show up. We don't want to leave out one of these options and only find ourselves with part of the answer with only one solution when we were really supposed to have found 2. So this is a very important element to the procedure. But as you can see with those steps, step 1, step 2, this is a very quick process. So when we have those types of equations that lend themselves to the square root method, yay for us. For instance, here in this first example, a squared is equal to 100. We don't have an a show up anywhere else. The a only shows up with that power of 2. And according to our first step, we want to get that perfect square by itself, but that's already been completed. The a squared is already by itself. We've got the number over there on the right-hand side, yay. We can move on to step 2, where, again, we're going to use the square root and square root knowledge, but we're also going to have to remember to use both the positive and negative options. So we can try to combine those together to, condense our work just a little bit more and make things look a little bit neater, and write down less as well. So we're going to express both of those possibilities together, a plus option and a negative option, or a positive option and negative option, or we could say plus option, minus option. So a lot of times you hear math people that would say plus or minus. So plus or minus, well, that square root, based on our understanding of square root, well, that can be simplified. So what we've got are these two different answers, and if we check them, we can verify that those both will be solutions to the equation. Likewise, for this other example shown up here at the bottom of the screen, let's go ahead and bring that up a little bit more and give ourselves some room to work. If our first goal is to get the perfect square by itself, then that means that our goal would be to get the x squared by itself. To get the x squared by itself, we're going to need to move the 72 and move the 8. To move the 72, we've got to subtract. To move the 8, we've got to divide. So when we subtract 72 on both sides and then divide by 8, we're going to end up getting a -9. In order to continue solving this, we're going to want to take the square root of both sides. When we take the square root over there on the right-hand side of our equation, we need to make sure that we remember that we have those two different options for our answer, the positive and the negative, or plus or minus. And in this particular case, we bring up one of our more recent discussions, that we would have, in this case, the square root of a negative number, simplifying to give us a complex answer, or, well, really an imaginary answer in this particular case. That square root, again, is going to be broken apart into two separate pieces. The square root of 9 would be handled separately, and the square root of -1 would be replaced by the I. And so to list these separately, we would have the two different solutions, and we could check these out for ourselves if we decided to do so. X equals the positive 3i possibility, and the x equals negative 3i possibility. Again, I do strongly encourage you to check your answers, check your solutions, make sure that they are correct. For these more unusual sorts of answers, that might be more work by hand rather than having our calculator help us out along the way, but still a very smart idea for you to take advantage of that opportunity. Well, both of these particular examples have in common that there's just the variable followed immediately by the power of 2. You can see peeking up here at the bottom of the screen that our next example is somewhat similar, but also somewhat different. That next example there still only has the variable appearing the one time and has the power of 2, but inside those parentheses, it's not just the variable by itself. There's that extra -5 in there to account for. So this has an extra little component to it as we are working out our steps. The same two basic goals, though. First, get the perfect square by itself. This time, the perfect square, well, is already by itself. That's that parentheses t minus 5, parentheses power of 2. That's the perfect square. That's already by itself, which means that we can move into the second step, which is to take the square root of both sides. When we take the square root of our number, though, over here on the right-hand side, we want to remember that we have those two options, the positive and the negative, the plus or minus. So, what we get on the left-hand side is that the square root and the power of 2 unlock each other and leave us with a t minus 5. Over on the right-hand side, we can simplify that square root by breaking apart the square root of 18 as the square root of 9 and the square root of 2. So just to include that one little extra step out here off to the side, the square root of 9 gives us a 3. Can't do anything more with the square root of 2, so we leave that alone. But we're still not done yet. We've got, in this particular case, one extra little step. We need to get the t by itself, and it's not there yet, like it had been with those earlier two examples. I need to get the t by itself using one last step where I move the 5 by adding on both sides. And just to make things look a little bit nicer and neater, if we take the 5 and write it first, then we kind of make the overall answer a little bit nicer and neater to the eye. Having that show up first where the plus or minus shows up in the middle, and any sort of leftover square root stuff might be showing up at the end. If this was a slightly different problem, that stuff could possibly have the I in it. So we would be more naturally leaning towards that complex number format by having that nice regular old 5 showing up at the front. So that's another reason why we're kind of fitting it in there like that, kind of looking ahead to if we had a complex number answer, we want that to come up a little bit more quickly. We don't want to have to focus quite so heavily on trying to rearrange things. Again, they're two different solutions though, and we want to write those separately. So t equals 5 plus 3 square root of 2 is one option, and the other t equals 5 minus 3 square root of 2 is our other option. And obviously with answers like these, we would need a little bit more time and effort to take those, bring them back over to that original equation and check them. Could we do so? Yes. And I still strongly encourage you to do that if you're talking about a quiz question or a test question that look like this. But for the homework, I can certainly understand that you might decide not to put in that extra time and effort to check an answer like one of these, or to check one of the complex number answers that might show up along the way. Let's bring that up a little bit further, see if we can still squeeze that last example in at the very top. And there's a reason why I want to keep that up there for just another few minutes. Completing the square is more of an irritating process for us to have to work through, especially when eventually completing the square is going to lead us to the quadratic formula, and having a formula is usually a whole lot faster to use than to have to go through a process like this. Completing the square is not only going to lead us to this quadratic formula eventually, but a little bit more on the surface of things. What this is allowing us to do is to create a perfect square, like the stuff we just saw in those earlier examples. And so this is why I wanted to keep this up here. If I didn't already have parentheses t minus 5 parentheses squared, if there was a way that I could create that, then I could use this square root method. So completing the square kind of ends up being, technically speaking, the first half of working through problems. Once we've done the completing the square, we have an equation where we can use that square root method. The situation would be if our variable stuff is not already locked up inside parentheses squared, what we would want to do is find a way of creating that situation. And so what we need to use is a pattern that occurs when we FOIL out things that look like this. So there's a way that we can come up with the fact that we need this to have a +1 here, and that we need to have a +1 here as well. And those are actually two different number ones. So to try to highlight that with a little bit of color here, what we're going to do is take the number as well as the sign that's in front of the plain old variable, we're going to always divide that by 2. And that's going to give us one of the special numbers that we need for the completing the square process. But we're going to continue on and do one extra thing there. We're going to take that green positive 1 and we're going to always square it. And that's going to give us another second piece to our completing the square process. And this time it's colored differently. Let's try to set those apart. The red positive 1 is the other thing that we need so that to use these the way that we need to. The second number that we get, the one that's been indicated in red, is the extra number that needs to be added on to my variable stuff so that I will be able to write a perfect square. When I write the perfect square, as it turns out, the very nice thing here is that as a bonus, the green number that I had come across is actually the number that appears inside the parentheses after my variable letter. So I've got the green number 1 and I've got the red number 1 that are being used in those two different locations. But obviously this is something that can change from problem to problem. So if we look for the special number that we need to create a perfect square and then also create the perfect square, I need to bring that up a little further for all of you video viewers. I'll come in and make an extra comment here at the beginning. Because I've got a plain old x squared out front, I begin my process by taking the number in front of the x as well as the sign. I always divide by 2 to get my green number, which I will see very shortly. But I take that green number and I square it to get my red number, and the red number is the first thing that I need to use. I need to take that x squared plus 20x and have an extra plus 100 on that so that I can write a perfect square. So that plus 100 is something that is important to us that we will be using in another little bit here when we begin to solve equations by completing the square. So that red plus 100, very key thing that we are going to have to recognize. But our overall goal is to create this perfect square, and again we've got this bonus sort of situation that inside the parentheses after the x I'm going to have always appearing that green number that I had seen after my very first little step here. So that green plus 10 showing up as the number inside the parentheses after my letter x, after my variable x. Let's look at this example together. Again, the first part that I want to come back to and stress for when we need to in the future, I have a y squared. There's no other number out in front of the y squared. So I have the y squared, and that means that I am now ready to begin my process of completing the square by taking the number in front of the y as well as the sign that goes along with it. So we've been boxing that in blue. We want to take the number and the sign that's in front of our regular variable letter and we're going to divide that by 2. That will give us, in this particular case, our green number, which is a -8 this time. But again, we're not done with our process. We need to then take that -8, excuse me, we need to take that -8 and square it in order to get the important red number, which would be a positive 64, or we could say a plus 64. So the y squared minus the 16y plus this special number that we were looking for. The special number is that red number that we just figured out here. Y squared minus 16y needs to have tacked on to the end the red plus 64. As soon as I tack on that red number, I will be able to write the perfect square, parentheses, it's not an x, it's a y this time, parentheses y something something parentheses squared. And again, what's going to go in those parentheses, there's my bonus setup, what's going to go inside those parentheses after my variable letter is always going to be that green number, that first number that I ended up calculating here in my procedure. Again, these steps come from if I take things like y plus a number, or y minus a number, or x. If I take those things and if I FOIL them out, what do they look like and how could they compare to problems like this, where we don't know what extra number we need at the end and we don't know what number we should have had there inside the parentheses to begin with. So we try to make a comparison, and that's what leads us to take that blue number and always divide it by 2. Take that green number and always square it, so that the green number and the red number are the two important pieces of this procedure that we would need to figure out, so that we can now use the idea of completing the square to solve an equation Now, the solving equation business is going to begin with that comment that I tried to emphasize on the previous two examples, that what I want to do is make sure that I have the right kind of setup here so that we can use the steps that we've just illustrated with those earlier examples. I want to get the variable terms by themselves. So I don't want any extra numbers except for my x squared and my x stuff. No extra numbers showing up there on the left-hand side. But to boot, a 1 in front of the x squared. So once I have that arrangement, I can work through my completing the square step with one extra little tidbit here. Because I am going to be incorporating that special red number onto the left side of the equal sign, I'm going to have to keep the balance by adding that same red number over to the right side of the equal sign. So a little reminder there about keeping things balanced. After working through the completing the square steps, though, I will have that special looking type of equation like our first examples from this video, where we can work through that square root method in order to finish solving the equation. Again, first example already worked out for us, so let's go ahead and run through the steps and how they line up with what we've been asked to do. Let me see if I can actually get that last little bit up there without losing the description of our first step. Almost there. Step 1, you get the variable terms on the left side of the equation by themselves, and I need a 1 out in front of the x squared. Well, it's not an x squared this time, it's a z squared, but comments still apply. So I want the z squared and the minus 4z by themselves, so I start by moving the 2. There is already a 1 in front of the z squared, so I don't have to do any extra tinkering to achieve that first step. Second step, work through the completing the square. I take the number that is in front of my plain old variable z, I take the sign that goes along with it, and I always divide by 2 to get my green number. Then I take my green number and square it in order to get my red number. The reminder up here is that when I incorporate the red number on the left side, I also have to do the exact same thing on the right side because it's a balancing act. As soon as I slap that red number on the left, I can write my perfect square, where again I've got that bonus situation with a perfect square has the green number showing up after my variable inside of those parentheses. Over on the right hand side, we've tidied up the 2 plus 4. And so the third part here, we can now work with this equation by using our square root method steps. Take the square root of both sides, remembering our plus or minus over on the right. And in this case, we've got to add the 2 on both sides in order to come up with our final answers, which we would then split apart and list separately to be perfectly clear with one another. So to have those listed out separately, the 2 plus option and the 2 minus option, giving us our 2 different solutions here. I've already included the little reminder here about how that completing the square stuff is going to go. I'm going to get something in blue, I'm going to divide it by 2, I'm going to get some green number, I'm going to need to take that green number, I'm going to need to square it to get my red number. That's always the same, so I kind of got a little template here. I just need to make sure that I start with the correct pieces to work through those steps. So that's my first step in this procedure. I need to get my variable parts by themselves, and I need to have a 1 in front of my x squared, y squared, z squared. This time it would be a y squared. So I like that I've got the 2y squared, and I like that I got the minus 2y. I don't like that over on the right side I've got the minus y over there, though. So I need to take the minus y from the right-hand side and bring that over to the left-hand side. So that would give me, I want to switch back over to my black. That would give me 2y squared minus y equals 3. So I like this because I have my variable stuff by themselves on the left side. I don't like this yet because there is the 2 in front of the y squared. So one little extra change in this particular example where I'm going to go through and divide everything by 2 so that I will have the y squared by itself. That means that that'll immediately be followed by a minus 1/2 y. And over on the right-hand side, also dividing by 2, I will get a 3/2, a 3/2 showing up there. So now I'm actually ready to use my completing the square template, and notice that I've automatically put that special number that I wanted into the blue box. What is the number and the sign that show up in front of my plain old variable y? So I'm going to take that negative 1/2 that I boxed in blue, and what we're really looking at here is basically taking that negative 1/2, and we can say that we're multiplying it by 1/2. Instead of dividing by 2, we can multiply by 1/2, still accomplish the same sort of thing. And what that gives us is our green number, which would be a negative 1/4. I need to take that green number and square it in order to get the special red number, which would give me officially a positive 1/16. So here am I completing the square steps. Now I got to take those red and green pieces and use them in their appropriate spots. So I'm going to come back to this y squared minus 1/2 y equals 3/2. I'm going to incorporate the red number first. So we would have y squared minus 1/2 y, and tack on the red plus 1/16 equals the 3/2 that we already had. And over on the right side, we also have to slap on our red number being added on plus the 1/16, because again, it's an equation, equals, same. We've got to maintain the balance. I incorporated a plus 1/16 on the left side of the equal sign. To keep the balance, I've got to put in the plus 1/16 on the right side. As soon as I do that, I will be allowed to rewrite the left-hand side in a much more convenient fashion. My left-hand side will now be the perfect square. Inside of those parentheses, after the y, is where we get that green number that shows up, minus 1/4, showing up there. Over on the right-hand side, where we've got the 3/2 plus the 1/16, we're actually going to have to do our common denominator, add those together, or alternately, maybe our calculator can bang out that calculation to our benefit without extra effort on our parts. So by hook or by crook, adding those together, we get a 25/16. So the completing the square process is done. Now I have that much nicer kind of equation that I can work with by using my square root method steps, where my square root method would keep me going by taking the square root of the left side and taking the square root of the right side, but also having that plus or minus option incorporated in there. So that would end up giving us, excuse me, the unlocking on the left side so that we'd be left with a y minus 4. Simplifying our square root business on the right-hand side, we would end up with a 5/4. Then we can continue with our one extra step here of getting the y by itself by adding 1/4 to both sides. So the 1/4 plus or minus the 5/4 is actually going to end up giving us these two different possibilities that we would want to work out separately. We cannot take anything for granted here about how things will work out. So we have these separate possibilities. Y equals the plus option. When I do the plus option, I will end up getting a 6/4 that can be reduced to the 3/2. The minus option would be giving me a negative 4/4, and that will reduce to a -1. So it turns out that what we have going on here, we actually didn't need quite as much room as I was expecting to use. Something that we can actually check for ourselves, but if we do so, I'll tell you what, let me actually backtrack just a minute and use that original extra space for an extra little thought that I have. These answers worked out to be rather nice. Even though we might not be super huge fans of fractions, they're still superior to having square roots, or therefore having complex numbers popping up. So the fact that we've got a fraction, and while it might not be super duper nice, it is at least nicer than the other alternatives. Having a -1, definitely a nicer answer, despite the fact that some folks still have an issue with negative numbers, don't feel very friendly towards them. These are nice solutions. Or it might be better to say nicer solutions. than roots or complex numbers. And if we were being a little bit more thoughtful, because these ended up being nice, what that really means is that they could have come from factoring. These could have come from factoring if we had been adventurous, I guess you might say, looking at the original equation, that 2y squared minus 2y equals 3 minus y. If we had been a little bit more adventurous and at least tried to get everything equal to 0, look at that and say, could we factor it? Then we might have maybe saved ourselves a little trouble. However, we want to look at this as the example literally is telling us that we're supposed to complete the square. So I didn't really have a choice. My directions forced me to do the completing the square. But if I had the choice, I could get these same answers from factoring. So I don't necessarily want to just forget that factoring is there for me. If I recognize that factoring could be used, then it is at least worth it to me to keep that option open. So, just to quickly and nicely state that we do in fact have these two solutions, y equals 3 over 2, y equals -1 for that particular equation that we've been given. Now, clearly this completing the square and then having to use the square root method to work the rest of the way through and arrive at our solutions can be a long and drawn out process, especially when I am being careful about the work that I write, trying to use colors to help me keep track of things. I don't necessarily want to have to put in that kind of time and effort if there's another way, a shorter, more efficient way of working through things. But it doesn't just come from thin air. So this quadratic formula business that was mentioned at the beginning of the video is something that comes from completing the square if we use a generic equation, ax squared plus bx plus c equals 0. So if we actually, or we watch somebody else do it, work through the completing the square steps where we've got, instead of actual numbers, a's, b's, and c's that we're tinkering with, and we're rearranging things, and we're doing our blue stuff gets divided by 2 and gives us our green piece, and our green piece gets squared to give us the red piece. And then I use my green piece and my red piece in their particular ways in order to come up with this. Eventually, through my square root method steps, I can arrive at this type of expression. And because it doesn't have specific numbers in it, just A's and B's and C's, it's a formula that we can use. If we can correctly identify whatever number is for the A, whatever is for the B, and whatever is for the C, we can put those numbers into that formula. We can use our simplifying skills in order to work through things and come out with the answers that we need, whether those answers are nice like these 3 over 2 and -1 answers in that example, or whether they're a little bit more unusual looking by having a square root that still appears, or if that square root has a negative number underneath, we would instead simplify all this stuff out and create a complex number answer. So whatever the case may be, we just plug and chug and simplify until we've got something that is a legal and simplified answer. Excuse me. So, to have this example here that's completely worked out already with all of the steps on the screen. The equation that they've given us, 6x squared minus 5x equals 4, is not going to cut it for using the quadratic formula right away. My quadratic formula can only be used if I have the blah, 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 blah equals 0. So the key thing before I can start using my quadratic formula is to move the 4 back over to that left-hand side by subtracting it. I've got to have my 6x squared minus 5x and the minus 4 equals 0. Once I've got the equals 0, I can now pick out the correct pieces to put into my quadratic formula. Yes, my variable is x, so at least I don't have to change that part. The rest of the quadratic formula is the same every time we use it. So we've got the negative b, we've got the plus or minus, the square root has the b squared minus 4ac all underneath of the square root symbol. And all of those things from the negative all the way to the end of that square root symbol, all of that stuff is on top with the 2a on the bottom. You've got to make sure that you're neat about this. Don't let your laziness stop that division bar too soon or start it too late. That division bar does not start underneath the plus or minus. It starts underneath that very first negative. That division bar, that fraction bar does not stop after the squared. It goes all the way to the end of that square root symbol. Just little things that I know sometimes people do because they're being fast about writing their stuff down, but still little things that can lead to a mistake. So, making sure that we've got that formula written down. Why do we write it down? Because if we write it down every time we use it, we're going to lock it into our brains. So, yes, my very strong suggestion to you would be, write the formula down before you pick out the numbers and put the numbers in the formula. Get that formula on your page so that you're drilling it into your memory banks, and you will have that at your disposal for the test and for future reference if you need to go on to other math classes. So putting those numbers into play and then starting to go through the process of simplifying. Putting those numbers into play. A is the number that is in front of the x squared. B is in front of the x. And C is the plain old number at the end. So I put those in their appropriate spots and start to simplify. I'm pointing already because I'm kind of thinking ahead before I'm speaking. The double negative becomes a positive. A negative number squared becomes a positive. And also, because our calculator can do some of this extra work for us as well, a negative times a positive times a negative, giving me a plus, a positive up in there, and then actually adding those as a separate step. The square root of 121 actually has a nice answer, so I get a nice answer coming out of that square root portion. And then I find that I am in the spot where I have to split these into their two options, the plus option and the minus option, so that I can work out those final answers that also, because they are nice, could have come from factoring if I had bothered to take the time to do that, if I had had the choice. Our instructions said we were supposed to use the quadratic formula, so we did. These same answers, though, could have instead come from factoring if we had taken the 6x squared minus 5x minus 4 and tried to use our factoring methods to work that out. So that is an option, provided that our directions give us that freedom. But of course, what we're focused on at the moment is using the quadratic formula, so let's use that for this next example as well. In this particular example, that quadratic formula would begin with a W equals. We can go ahead and move right into using that quadratic formula because our equation has the blah, blah, blah equals 0, which means that we are equipped to already start identifying the A, B, and C numbers
that would go into our formula. But my encouragement again is to go ahead and write that formula down before you pick out numbers and start plugging them in. Burn that formula into your memory banks so that there is no issue whatsoever when you sit down for a quiz or a test and need to pull out of your memory banks what that quadratic formula actually is. Now, in this particular case, we want to identify the A, the B, and the C. So we would have the A as our number in front of the W squared. That's a 2. We would have for the B the number that is in front of the W, or we could also say in between the W squared and the W. So that is a -5. And then our C is the plain old number that shows up. What color did I use the last time? Yes. The C is the plain old number that appears at the end, which would be after the W, we have a +7, it's +7. So these are the numbers that we would need to plug in for the A, the B, and the C. And then everything afterwards is a matter of working through the simplifying steps. So, starting out, we have the negative. The B number that we have determined here is a -5. Our formula continues with the plus or minus, and then starting out that square root. Inside of that square root, we're going to have that -5 show up again, but our formula says that we need to square that, followed up with -4 times the A times the C and that square root symbol needs to extend all the way to the end of that C that we just wrote down. So there's that square root symbol extending all the way to the end, and then our formula also says that for the rest of this stuff we have to have our fraction bar that starts at the very beginning of that negative symbol and goes all the way down to the end of that square root symbol. So, bam, big old fraction bar or division bar that we need in there. And underneath of that is where we have our 2A. So again, A getting put into our formula in its appropriate spot. So there are our numbers put into their spots, and everything else that we have to do, all the rest of the work that we have to complete, is a matter of simplifying as much as possible based on our knowledge of, well, square roots, order of operations, simplifying fractions because of that fraction bar that's showing up there. So if we go back to the beginning of our formula and take a look at what we have, there is the double negative, which would become a positive. Underneath the square root symbol, a -5 being squared would give me a positive. A 4 times 2 times 7, 4 times 2 is 8, 8 times 7 is 56. Down on the bottom, 2 times 2 is 4. So our denominator showing up here, 4. Underneath that square root, we've got the 25, minus the 56. That square root having a negative number means that we can officially rewrite that, and we have the choice of either putting the I in front of the square root or after the square root, whichever one you like best. By habit, I like to put it afterwards. That's just me and my own sort of habit from my own educational background. But I can't do anything more with the square root of 31, so sadly that's going to have to stay. Four still on the bottom. Now we've simplified as much as we can because 4 doesn't go into any of the stuff on the top. We can't simplify the square root anymore. So just as far as the standard kinds of arithmetic work, we don't have anything else extra in terms of legitimate simplifying. The only other thing that we really need to worry about is that nitpicky aspect of, because this is a complex number answer with the I having showed up here, and my fraction bar does need to actually go all the way underneath that I. So with that I showing up here, we have a particular appearance that needs to be in our answers, where that 4 gets slapped underneath of the 5 separately and gets slapped underneath of the square root, or I should say the 4 gets put under a fraction bar below the square root of 31, and the I is going to follow up at the very end there. So there's my official format for those complex numbers, but as we've done with all of our previous examples, we want to take those answer choices and write them separately. So again, we were trying to find W, and that means that W is equal to 5/4 plus and W is equal to 5/4 minus So there are our 2 solutions, each written individually, that take care of this particular exercise. So, for some of you, you're going to look at this and say, quadratic formula, I plug numbers in, I can do simplifying, and I can certainly use my calculator to help me out along the way. I like that. Other people, and though it's more rare, might say, well, you know what? I actually kind of like that, completing the square a little bit better, because having to do all of this simplifying one step at a time just can look a little bit overwhelming. Well, when you have that choice, take advantage of it. Completing the square will always work no matter what kind of equation you have. The quadratic formula will always work no matter what kind of equation you have. Sadly, factoring doesn't always work. So if we spend time factoring and find that it doesn't work, well, isn't that kind of wasted time? If we tried to use the square root method, but we weren't really equipped to do that at first, well, that would be a waste of time. So we do want to try to be thoughtful about what we're doing. We want to try to use our experience to its fullest extent. The experiences that we've had with factoring and the experiences that we've had with solving equations by factoring will hopefully help us more quickly recognize when it would be a good idea to try factoring. And now, having the quadratic formula, for most folks at least, that is going to be the other choice that would be made. If I don't want to worry about factoring, or if I found that factoring didn't pan out, let me jump into that quadratic formula, bang stuff out, and come out with my answers. So again, when you have the freedom to do so, that's a wonderful sort of opportunity. But if your instructions specifically force you to use a method, make sure that you do follow those directions.